IQ, and basically I've been in mobile security for a while. It's really where I focus a lot of my security passion at. I wanted to give a quick overview of what I'm going to go over. There's a lot of issues with Android applications. The main way malware is getting onto the phones is through applications. And as security researchers, we needed ways to analyze them. Fast, quick, automated ways. There's two main methods that are being used, and that's static and dynamic. I'm going to go mainly over dynamic. That's what we really leverage and use, especially for the Android. We do static as well, and I'll touch on what static is. And I'm going to go through actually how to use dynamic, how to take the Android source, which is AOSP, and use it for dynamic analysis and the techniques that we use. And using those techniques to find malware, and then best way you can automate everything, and then hiding applications that you're actually analyzing, hiding it from you. So this is a quick agenda that I'm going to go over. So like I was talking to, there's two main parts of analysis. There's static and dynamic. And static is almost always analyzing the application without running it. It usually involves disassembling, decompiling the application, breaking it apart, looking at it. The problem with static, even though it is a great technique, is you can only know what the app can potentially do. In a lot of ways, you might see it do something, but it might never do it. It might never reach that point in the application. A good example would be SMS. You might see in the application it can send an SMS, but it might never do it. And that's kind of the beauty for dynamic. Dynamic is an analysis of the application while it's running. So you're actually running the application, you're looking what's going on underneath. So it's going to do it if you see it in dynamic. There's no really disassembling. Usually it's at runtime when you do it. And you put in instrumentation routines. And I'll get more into that, what exactly instrumentation routines are. There are other methods for analysis, but these are the two main approaches that security researchers use for analyzing applications. And how does AOSP fit into this? Okay, the AOSP is basically the Android open source project, and it's led by Google, and they maintain the Android source code base that all the phones use. The carriers and manufacturers might modify it some, but underneath it is AOSP. It's from Google. They have a team that actually does the code, and that's when I say AOSP, that's the Android open source project, which is basically, for all intents and purposes, the Android source code. The AOSP project is the build tools to actually compile Android and get it running on a mobile device or an emulator, which is what we're going to use. For dynamic analysis, AOSP comes into play because the source code can be modified with our instrumentation routines, and we can actually see what the application does because we're going to modify the Android source and put in our own little routines and watch and see what it does. And we can watch why it's being executed. And I listed a few of the behaviors that you can do: file, network, telephone. So for all intents and purposes, AOSP is the Android source code, and it provides everything we need to do dynamic analysis. This is just a quick step on how to get Android. You can go to developerandroid.com. It's all open source. You can grab the full Android source tree and run it and create your own version of Android. And that's just a general overview of the directory structure that it looks like, which I'll get more into in the next few slides. So this is kind of the AOSP, the Android source is, this is the Android source. The layers are not even the layers, but the components of it. So you can see in the top right the application that's being ran, and it goes through all these different layers. And the top is the Android framework, and that's the telephone, the activity manager. And some of you might have heard about the Dalvik VM. The Dalvik VM really resides in the top layers of this. So everything that's ran goes through JNI Bridge, and this is the native Java. It takes the Java code and goes into the native code side of things. And then that's the Apache, the libcore, the Bionic. Those are really C code. So from the JNI Bridge down, at the top it's Java. So when a person writes an application in Android, it resides up in the framework. I mean, they can do some native stuff, but usually it's in Java. So it goes to the JNI Bridge, and then The native stuff runs what it needs to do, and then go all the way down to the kernel, then the hardware layer. So in the general overview, this is where the layers of an application goes down. So this is the Android source. Now, for our instrumentation routines, we want to target parts of this. We want to have a view into different parts of these. So if you look at the Android framework, it's kind of fuzzy, sorry about that. So at the top, you can see there's the telephony manager, and you got the SMS manager and location manager. The top one is all the calls to get more information around the device, like the IMEI number, ESN number, and the identifier numbers. And you got also an SMS manager, which is used to, everything goes through this to send SMSs. So we want to hook, these are places where you want to hook in and see. And then you get the location manager, which does all the GPS tracking. So these parts of the source do those things. And then below that, you have the actual JNI bridge. And the JNI bridge is where, as I was mentioning earlier, the bridge between the Java code and the native code. And you can hook into this. I wouldn't recommend it. I've actually hooked into the JNI bridge. There's a lot of noise that goes through because you imagine everything at the top layer has to go through the bridge. So you're going to get a lot of noise. And then below that, you have some more of the native stuff. And these are the actual, you're getting closer to the kernel. So you have like the native crypto calls. You have the file calls, which is the POSIX. The native crypto calls would be the SSL, and the encrypted SSL, an open SSL that applications use. And then you have some of the raw socket calls, like in the Bionic, which is the shared glib that applications use. And then you can hook, we want to hook into all these, but I can tell you right now, if you hook all the way down to here, the bottom, the receive, you're going to get every packet, encrypted, unencrypted, everything. So that's where, like the native crypto is that's a good place to actually hook into because you'll get the plain text. You'll actually get the unencrypted network calls before they're actually encrypted and passed down to a lower layer. And then you also have some of the hardware calls that you can use, which is the radio layers. And those are kind of fun to look into as well because you'll get everything that's being passed. You see the dispatch dial, the SMS calls. A lot of the radio functions you can see, the GSM calls and all that stuff. So this is pretty much the full source. And like you said, these are just some interesting parts that I picked out specifically. There's a bunch of parts you can pick out to hook into and look at. So now we've identified what parts of the code we'd like to see in application and what behaviors. And like for the SMS, we want to see all the SMS calls that an application may make. So we'll go into the SMS manager and modify it there. So now that we've identified like all the places that we want to hook into and instrument and see, you need the second step would be create your own version of to take the actual code, the Android code, compile it, and get that up and running. And then after you get it up and running, then you can go and add these instrumentation routines. One thing that we've used to actually instrument is we use the ADB logger, which comes with Android. And I've gave examples of how you would go through and the Java part, you just call that and pass your log routine in. The C and C++, you can use the macros that come with Android. And the Bionic, which is really the native stuff, they've also provided a way to pass logging through the ADB debugger. So Android has already provided ways for you to put stuff in if you want to use the ADB logger, which is what we use. You can also roll your own, I guess, way to do it, but ADB seems to be pretty robust enough to put in our instrumentation routines. To give an example, if you were going to hook the SMS manager and put your instrumentation routine, it would look something like that. So that's you have the call, the SMS manager, you have the syntax message, and then the destination address and text message. So an application will actually call this. And if you want to do a log, there's the logging command right there to pass it through. In the live demo, I'll show more how to do that. Like I was saying before, watch out when you do these instrumentation routines because it can get really noisy. And you lose a lot of context, too. The data the hooks will, for an example, if you hook all the socket calls, it might be encrypted socket SSL communication. So you might want to step up and actually hook the OpenSSL libraries before it actually gets to the raw socket calls. So the lower down you go and the lower you put in your instrumentation routines, it can get more noisy. A good general thumb, if you're in the kernel and you're putting instrumentation routines, like all the file calls, all the network calls, it's usually going to be a lot of random noise. I mean, in my experience at least. Okay. So this quickly goes over how to add a mobile app to the emulator and sending it. And some of you might already figured out how, okay, so if you're dynamic and you want to see all these behaviors, how do you make the app do these behaviors? Which is definitely, it's a complex thing to do. There are some tools to actually automate the app and make it do things. It's called Monkey Runner. There's a monkey application. And these all come with the device from Google, part of the Aosp tools. And one is called Monkey, which you actually you can spin up and simulate random clicks and actually run the app and run it and have it do certain things. I've had more luck with the activity manager command. So a lot of applications, when they run, especially malware, they'll wait for an SMS to come in, and then they'll trigger the behaviors. You can broadcast the event that an SMS was received on the phone, and then all the apps will see it, and they'll think an SMS was received, and then the behaviors then the malware will actually start calling the right routines that you want to hook. There's still, there's also some more instrumentation tools that come that you can actually run more of the interface. I found a lot of ways is to look static-wise what an app is doing. So we might see that it does send an SMS message. I'll have it trigger like a bunch of ways to automate SMSs on the phone. So it's one way to do it. And another thing to trigger the behaviors is to realize that since we're hooking all these calls, we can also have it return something that'll trick it. Like if it's a time-based application that's waiting when a certain time event occurs, you can hook, how it's getting the time, so you just hook the time calls and have it return a date way in the future or just some random dates to have it trigger the activity. I haven't seen any yet, but I've also been asked, what about applications that are using GPS? So they're waiting for a location, so it could be like in Pakistan, and then if it sees it in Pakistan, then it does the behaviors. You can also trick an app. Since we're hooking the GPS calls, we can also have it return different locations. I haven't seen any applications or malware that really trigger that sort of activity, or they're triggered off like locations. But there's certainly ways to trick an app to have it do something. And you'll never be 100%. You'll never be able to exercise all the activity for an application, but you can just try your best. The Monkey Runner is pretty good because it does try a lot of clicks and putting in passwords and trying to get a lot of behaviors that way. This does get tricky in dynamic analysis if it needs a login and password to pass that. And in that case, if you're going to have to get it, you're going to have it read user and password, so it'll skip the user and password screen, so then you can see more of what it's doing. That's a little tricky, and there's actually probably ways where you can trick it to where the user password already happens and then does the behaviors. But it does get tricky trying to exercise all the behaviors for an app to see what's going on underneath. But there's ways. I'm going to step through. Hopefully the rest it'll come through. I'll step through actually how to instrument and hook the SMS call. Let me bring this up. So this is the actual source for the Aosp source I was talking about. You see it's got the development and frameworks. And you can see over here, again, sorry about this is the actual sending a text messages in the source. all apps go through here to send a text message. This is the call they usually use. This is it. So if we know if we put a little logging routine here, we can actually see the message that was sent and the SMS call. So here's the actual getting the log and sending it through. In this case, you see I'm encoding the message because if I'm parsing and trying to see what's going through, if it's just binary, it's going to mess everything up. So in a lot of cases, you'll find, especially for network calls and file calls, you need to encode it with base 64 before sending it out. So that's the first thing. And then if you go, let me go and I'll show you actually spinning up the emulator. So we hooked our call. Actually, I didn't show this step, but what I would do is I would actually compile the source. Hold on. I have another window here. Yeah, if you want to, this is me. So you modified it. Here's how you would compile. Just run a make command. It's actually compiling the whole Android source. But it's already been pre-compiled, so if you just change one part, it'll just compile that one part. The first time you compile Android, it takes about an hour, at least. But once you start changing little parts of it, you don't have to recompile the whole Android source, just that one little part. In this case, I create an ISO image, and I would copy it to. You can copy the ISO image to our emulator. Let me show you the emulator now. So basically, I'm going to run the new version of Android I've compiled. Again, I'm sorry about the resolution here, but you see this is a new version of Android that we're spinning up. And the camera doesn't seem to work on it either. Oh, I see. Hold on a second. Let me copy the server. 1 second. One moment up over more. This can be a little tricky because of the resolution. Okay. One second. It flipped the screen, so I gotta figure out the way this mouse works. One second. I'm going to bring up the app in a second on a different screen. Okay. Okay, so this is the version of Android we got up, and now I'm going to install some malware on it. Show you how that looks. One second. 20. So for my desktop, I'm going to install some malware. I have the actual Android binary, so here's how you install it. ADB install. So it just installed an application on here. I'll show it to you in a sec. If you go over here, I'm sure some of you have probably seen this malware before. So one second. Okay, now this is kind of a view into it. So these are the actual intermediate routines. So if we trigger something on here, I'll show you how it looks here. You can see underneath it's doing all this activity. So what do we see? Try to connect to a network. Well, it's doing a properties get. Oh, here we go. Okay. So what you're seeing here, that SMS thing we just hooked, so the app actually called it. And then it's tried to send a text message, and here's the destination address, source address. I didn't even know. So you also see the honey token mobile number. So in the message, actually sent the mobile number. So yeah, I mean, it worked. So yeah, that's the basic. I mean, that is the basic for dynamic, and you can see the other activity. So if we keep running it, it seems like I only sent that once. You can see the token generator. That's named the malware application. It tried to go to a domain name too. So we can see it tried to go here. I don't know what that is. Try to send data out there. You can see how like just so much more than an application does by doing this technique. So that's the basic, of running an application and seeing what it does in dynamic. back to my slides. All right, so yeah, I mean, this is just a general review of what I just ran. You can see the values that came out when we actually ran the application. So one thing that we actually encounter after we do all this dynamic is people that will submit an app that actually look and try to break out of the dynamic engine. I know that happened recently, Charlie Mueller and them. And they actually use Google Bouncer. There's a program called Google Bouncer that's at Google they use. So all apps that are submitted to Android goes through the Google Bouncer, and they broke out of it and actually talked to. The only defense you have against applications that are trying to break out is to sandbox everything. And a lot of them use the runtime call. They'll try to execute a system command, the application. You got to remember, since we have the full source, we also have the source to runtime exec. So we can see when an app calls runtime exec, and we can see what commands it's going to try, and we can return whatever we want. And I mean, you really got to sandbox everything, though. I mean, anything that can break out in the Dabble VM or go native code. And we can't protect against anything in dynamic, but we try our best. Yeah. So that's a quick overview. I mean, again, there's static and dynamic. Dynamic's been working well for us. It's more tricky in other platforms, but for Android, since you have the full source, you might as well go in there and hook all you can. I mean, I just covered a few parts of the source, the instrument and routine. There's tons of other parts to it. I know there's the intents. There's all the phone call routines, any of the recorder routines, anything that does the microphone. You can hook all that stuff and put your little routines in and see what really runs, what's going on in the application. One thing, I love the running on emulators as well, because you can run it in the cloud. I mean, you can run these emulators in the cloud, so you can take in a bunch of apps and scale up in the cloud. So it seems to work well with the emulator. I used Android 86 here. There's also other emulators you can use as well, but Android 86 seems to work pretty well. So that's my talk. Any questions? Yeah. There'll be some questions.
Aló, acá, Marco.
Yeah. That's going to be a tough one.
Hey, thanks. I have a question. How do you compare with existing dynamic sandboxing system, such as Andrubis, that is like an extension to Anubis? I don't know if you know it. I mean, it's a system where in Anubis you can analyze malware for the desktop that run in a sandbox. Since a couple of months now, we have like a plugin that is able to analyze APK file for Android. So basically, they instrument like the Android app, and they can trace like if it's call and which kind of action that the malware does.
Oh, are you asking how you can do it with Android?
How do you compare with them? I mean, what's
it's
more innovative in your technique compared to existing one?
Yeah, I mean, I know at McAfee we did the same thing. I mean, on the desktop for Windows, we'd sandbox it, do some syscall hooking, and actually see what it does. It's not a novel technique, but it's a lot easier with Android. It's easier. That's just the thing. It's much easier. We don't have to do syscall table patches like we did because we have the actual source code. So there really isn't. Again, it's not a novel technique. I'm just taking it and applying it to Android. It is more of a novel technique to do on iOS. That's a different beast. To actually do hooking and syscall or do a dynamic analysis on iOS. But yeah, it's not novel, but it works. I mean, it's a lot easier to do. Yeah.
You're just building your own system, so you know what's going on there.
Yeah, it's an open system.
Because you don't trust the other one.
What?
Because you don't trust the other one.
Because
you cannot use them. You cannot use a McAfee one.
If
you are not in
I don't think there's a framework for doing dynamic analysis for Android, is there? I mean, I'm not aware of a framework to do dynamic. For Android, I don't know if there's a framework to do that.
There is one called Anubis. It's a public service, so you can go on anubis.isaclub.org.
Really?
You can submit your application for Android, and you have this framework that analyzes the application and give you like a report. So it can tell you like this application is sending SMS, this application is intercepting audio, or is dropping file on your mobile phone.
Does it just use dynamic analysis?
Yeah.
Because
It's not static, it's dynamic. I mean, you just it's a sandbox
Yeah.
that analyze your dynamic.
Sure.
It's exactly what you're doing here, so I'm asking what's the difference? But
I think we're probably hooking a lot more places. We've automated it probably in a lot better way. Maybe I have to look at the reports. I haven't seen the reports from this, and I don't know what all the parts of the Android source they're actually.
yeah, maybe it's
working with.
worth to check it. It's
Yeah.
anubis.isaclub.org.
Absolutely. Well, remember, static is just one part of the analysis whole life cycle. I mean, you should be taking static and dynamic together, and you should be looking like the market. There's different analysis phases. I mean, there's like 4, and they should all be working together. That's what we do. It's just one part, the dynamic. But if it's just dynamic, I mean, you can do that, but you still need the other static parts to work together. But it might, yeah, I'll check it out, definitely. Yeah. Is it open source, this project?
You can submit the sample to be analyzed for free, but they don't provide access to the code.
The actual
Actually, the
hooking code.
service is free to use, but it's not open source.
Okay, cool. Well, I'm glad somebody's doing more. That's great.
But I know the guy that designed it, so I mean, if you have questions, I can point you to some papers or
Yeah.
people.
Again, more people looking and doing this, actually, the better. Yeah, that's for sure.
Gracias. ¿Alguna consulta? ¿Pueden hacerla en español también? ¿No? Bueno, muchas gracias, Kevin.